Very good evening to everyone in the world. And then, of course, some of you may not be having evening, maybe good morning, good afternoon. All right. And so we are from the Astronomical Society of Penang, and which for some years already, at the end of every month, on the last Saturday of every month, which is today, 26th of March 2023, we present our APOD. APOD is not the piece in the pot. No, APOD is Astronomy Pictures of the Day by NASA. Right? Remember, I've been following APOD since 1995, Ryan. Beautiful, you know. The best picture you can find from the airport is in the airport, as well picture made by NASA. So today we have our presenters, what you call, of course, we have our Marcus Chin there, all right?
Hello.
Marcus, okay, wave your hand. And then Rayan also, Rayan, okay, and Sunit Singh, okay.
Hi. Hello.
These are our young as well Society of Penang members, ASP members. Okay, so Marcus is still studying in high school. Okay, and Rayan is, of course, we know Rayan is very special case. We wish him all the best. Okay, so we hope that he'll pursue a career in university. All right, up to the highest level, international standard. And Sunil also. Okay, Sunil has just finished his Form 5 studies. He's a student from Chongling Astronomy Club. All right, and he's already accepted, so he will be pursuing his university studies soon in Malaysia. All right. So I also wish Sunil all the best for his studies. All right. So I'm Dr. Chong Hon Yu, what they call chairman of the Astronomical Society of Penang. So we start today's first picture, airport of this April 2023. All right. I'll share my screen. Can you see my screen? Can? Okay.
Yes, we can.
Okay, thank you. So first one is, wow, I like the word they put in, wondrous. Okay, people who explore around without any aim around the unit of the solar system. This is called wondrous. I like it. So of course, the visual is created by this person, Eric Benquist, on the visual, and of course the music by Christian Sampit, and the words and voice by Carl Sagan. But I'm not going to say anything. You all watch it. It's about 3-minute video. I really like it, right? So remember, our Carl Sagan is a famous American astronomer who popularized astronomy a lot, even in the TV. Of course, he's always a great researcher, all right? But he passed away in 1996. That means the voice that you hear was recorded before 1996, all right? Remember, Carl Sagan came up with a famous series called the Cosmos series, the personal voice, which also showed in Malaysian TV in the 1980s. Very popular series that inspired millions of people in the world to pursue astronomy. Some of them pursue astronomy as a career. So basically, as the video and sound goes on, I'll put in some words here and there. Okay. So we start out now. The Wanderers by Carl Sagan. Now, this is in future. In future, a spacecraft above the Earth's surface. In space above the Earth. In future.
Dr. Chong, is that supposed to be audio?
Okay, no, this is in future a spacecraft over Jupiter. You can see Jupiter.
Okay.
And this is above the Enceladus. The moon with the tiger stripes above Saturn. The water spraying out one. Okay, these are the rocks of this.
We can't hear sound. Dr. Chong, we can't hear any sound.
Wait a minute. You cannot hear anything.
No.
Wait a minute. But I'm playing it, you know.
Is there a way to share?
In that case, can you share on your screen? Because my screen, I'm playing it. I can hear the sound very well.
Okay. Let
me
me
play
see
on your screen. I'll share my screen now.
Okay.
And share
I
you.
need to see if I can share computer sound. Okay.
No, but when you share your sound, when I speak, it will not be recorded.
Can you see my screen?
I don't see your screen. Now I can see your screen now. Can you
Okay.
play the video?
Let me get to the APOD. One moment.
No, in that case, I tell you what, I will not give my any voice command. You just play it from your side. The visual and the video and the sound. All on your side. Okay?
Okay, wait, let's try this.
So I share now from my screen. Okay, all over to you.
For all its material advantages, the sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood.
Can you hear me, Ryan?
Yes, I can.
Okay. So now it's spacecraft above the Earth. Space above the Earth. Play. Continue to play.
Can you hear the music?
I can hear the music,
Okay,
but
that's
now
good.
your video has been paused.
Okay.
Well, then it's obviously around Jupiter.
We have far off places with a certain romance. The appeal, I suspect,
Enceladus, the moon with water coming out from Saturn. Play.
element in our survival. Long summers, mild winters, rich harvests, plentiful land.
Around Saturn? In space there.
Over bands. Original species might be owed to a restless few, drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds.
Mars. Mars. In future.
Herman Melville in Moby Dick spoke for wanderers and marines. He said, I am tormented with an everlasting itch for things remote. I love to sail forbidden seas.
Moon orbiting Saturn. Approaching an asteroid. Look at the long teeter. Fantastic. Walking on Europa, one of the moons of Jupiter. On Titan, the moon on around Saturn. I see moon Europa. No. Uranus. Saturn.
It's a little early. Maybe the time is not quite yet. But those are the worlds promising untold opportunities
Saturn.
beckon. Silently, they orbit the sun, waiting.
Well, thank you, Ryan. So I really like this video because you see, I'm saying this Yahoo. Great. So it shows in future, maybe I don't know now, 1 or 2 generations from now, when man is slowly colonizing the whole solar system, this could be the scenario, okay? That we know all these places before the great red spot of Jupiter, Enceladus, the moon of this Saturn that has tiger stripes and water, but we have never been there. But in future, our maybe one of you in future or our descendants will be able to actually go there and explore. These are the wonders of the solar system, as explained by our Professor Carl Sagan. Okay, so now we go to the second what we call picture. For me, it should be, which is the 14th of March. Okay, Bori. W5, the Soul Nebula. Very nice, no? Nice thing, the Soul Nebula. So it's actually taken by one Spanish amateur astronomer called Jose Jimenez. Okay, so I hope everyone, especially Ryan and Sunny also, our Malaysian don't know how to pronounce the European's name. So it's actually Jose Jimenez, amateur astronomer from Spain. He took a picture. What camera he took, what telescope he took, what exposure is not important. Because previously, years ago, when the APOD came, they actually would give what telescope and so on. Now they assume that you, as a person who go through APOD, you already know what it is. But who is the person is more important. Jose Jimenez from Spain, and it's Sol Nebula. And actually, we know that it is in Cassiopeia, Queen of Ethiopia. All right, and this, of course, we know that this nebula is called because that previously there are some earlier generation of stars that died, and they throw out gases, clouds of gas and dust, and this is can be seen. Okay, and because we know that the atoms in space there will be excited by the stars there to give out light. Okay, for example, they say that red, of course, is by hydrogen, which is hydrogen alpha. Okay, and then you have the yellow by sulfur, all right, and blue by oxygen. And by the way, these colors are not the blue and green, yellow, and the red on the earth. These are all discrete lines, spectrum lines. But our eyes cannot see the spectrum line. But you got a spectroscope, you look at this red part, hey, you can see actually discrete line. All right, there's no continuous red line. It's a certain wavelength in the red. For example, 560 nanometers. That is our hydrogen alpha line, the red color. So these are all discrete line. The Soul Nebula. And remember, this is, of course, also very close to another nebula, not shown here, called the Heart Nebula. So it'd be great if, sorry, I use the word, if one of you take a picture of the Heart Nebula, say in some dark location in Malaysia, and then next to it, you take at the same time a picture of the Soul Nebula and give it to your girlfriend. Very nice, Heart and Soul Nebula. Okay, so now we go to the next person. Sunny, for you, next. Yeah,
Okay, thank you, Dr. Zhang.
Yes.
So now I shall, let me present. Okay, can you guys see my screen?
Yeah.
Yes.
Can see.
Yes.
All right. So, okay, so this is the first picture of the APOD that I will present, which is from March 21st. And this picture has the title of Dark Nebulae and Star Formation in Taurus. And it's taken by an astrophotographer, Vikas Chandra, which is an Indian astrophotographer. Now, as you can see that this picture is quite, we can say, dusty. As you can see, there's a lot of these nebulas or a lot of dust flying across the sky. And somehow you can see there's something weird, some object at the middle of the whole image. And this is what we call it the Tauri. There's a star, this Tauri, and this actually the nebula, this small thing little here is called the Higgs Variable Nebula. And yeah, so what we're looking at is basically just one small nebula and that Tauri star. Now, the Tauri star is a variable star discovered very, very long time ago, and it's also one of the first variable stars that's discovered in Taurus. So this object is around like 400 light years away from Earth, and apparently, since that it's in Taurus, right, this whole dark nebula, this image is also quite relatively close to Pleiades. And as you can see that there's a lot of this dust around here, so it's it indicates us a sign that some of the stars are still in the formation phase. So what we're looking at is a lot of these stars are actually still very, very young, and they're still quite unstable on their own. And as time passes by, they'll start to become much more stable stars, and then in the end, it will become an ordinary main sequence star, which, most of the stars spend their whole lifetime as a main sequence star. But currently, all these stars around here, most of the stars around here are yet to be a main sequence stars because they are still very, very young. And because, all of these supernova remnants, they are actually some of the first stages of a formation of a star. So you can see at this center part here, the dust in this region compared to the region apart from this here. So you can see the dust here is not actually that concentrated, but at the center area, the dust is very, very concentrated and it just clumped together. So this is also indicating that all the dust, they are clumped together gravitationally, and it's going to form maybe a few new more stars around here compared to this area. So because this is quite more concentrated, so we can expect that there's much more stars that's going to be formed in the future around this area. So that will be it for this picture, and I'll move on to the next. So, right, the next one will be the picture for March 16, and this is an easy one for me to present, because this is Omega Centauri, and I believe that this is quite a popular open star cluster, globular star cluster, and it's quite infamous when it's in this astrophotography field. Almost everyone knows this Omega Centauri. So yeah, things to say that is that this is titled Millions of Stars in Omega Centauri, and it's taken by Neil Corp, which is an American astrophotographer. And so some fun fact, this star cluster Omega Centauri is around 150 light years across, and you can see that there's a lot of these blue and reddish stars. So the blue stars indicates that these are the young stars that's been just formed, and the orange stars are the stars that are starting to die, the stars that are already at their old ages. So yeah, we can see there's a lot of orange stars over here, so it means that this star cluster may be a very, very old star cluster, maybe a few million years, a few 100 million years ago. Yeah. And another fun fact is that there's one theory that this Omega Centauri, before this star cluster was formed, it was initially a galaxy. And what has happened? What happened to that galaxy? Why are we looking at a star cluster instead of a galaxy? Because I'm saying that it was a galaxy before. So what happened is that our Milky Way galaxy is also already very big, but for this Omega Centauri, before then, when it was a galaxy, it may be a very, very small galaxy compared to the Milky Way galaxy, and they may have collided together, and then since that Milky Way galaxy is much more stronger and bigger than this Omega Centauri galaxy, the tidal forces of the Milky Way galaxy will just tear the whole galaxy apart. So it means that now the stars at the quite outside area, the outside stars, they are torn apart from the galaxy. They are already pulled apart, but you can see that there's still the core of the galaxy before, and now it becomes the core of this star cluster. So yeah, currently we can say that this star cluster used to be a galaxy, and now it's living inside the Milky Way galaxy. So that will be the picture for March 16. and I shall move on to the next. March 12th. Alright, this is quite an interesting
Beautiful.
one. Yeah.
Good
So,
for bathing.
so if you take a guess, you might think that this might be a comet or what, or some, some objects at the asteroid belt. But no, this is actually not. This is actually a moon in the planet Saturn, and it has a title Saturn's Hyperion, a moon with odd craters. So you can see all the craters. Some of it are quite normal and ordinary, I would say, but some of the craters, they can sink down very, very deep, and we can almost see that we can't really see the end of the crater. So this image is taken by the spacecraft Cassini, and also processed by NASA and all the team, the imaging team. So Cassini is a spacecraft that was launched by NASA to the planet Saturn, just to further study more about Saturn and also some of its moon. So this is one of those moons from Saturn, the Hyperion. So what makes this moon so weird? Why isn't it like why isn't it like our moon? Our moon is round, but this is just irregular, I would say. So as you can see, it has a spongy characteristics. So actually, this moon is not very dense compared to our moon and some other moons. It's very, very less dense. So it means that the center part of this moon, the core of the moon, may be a cavern or a cave. The inside of the moon is not as full as we are. It's not that full. It's a bit empty. So there's a lot of space, a lot of caves inside this moon, which makes it very, very less dense and give this spongy looking shape.
Maybe many aliens are hiding inside the cave.
Yeah, maybe there could be another alien civilization inside there hiding from us, and they are secretly spying on us. And another thing is that this moon is actually not really covered. This surface, they are not really rocks, but instead most of the surface is covered by water ice, and perhaps also some of methane and ammonia ice. Yeah. So it's like the moon? The moon Titan, also from Saturn. So Titan has also have some methane. Is it methane lake? Yeah, some of methane lakes and also methane ice mountain. So same as this, some part of this Hyperion moon is covered by methane ice. And also is that since that we can only observe this Hyperion with Cassini, we can't really observe this small moon because it's around 250 kilometers in diameter. We cannot observe this moon from Earth. So it means that we need to send this Cassini spacecraft just to have this image, this high quality, high resolution image, to be transferred back to Earth for the scientists to study. And then Cassini, after taking his picture and also try to send a lot of data of Saturn back to Earth. And in 2017, Cassini has already, in his final days, in his final stages, is about to die. So NASA decided to purposely crash Cassini into Saturn, just to, if you don't purposely crash the Cassini spacecraft into Saturn, the spacecraft might collide with some other Saturn's moon, and then the moon will be contaminated by some of the oils inside the Cassini spacecraft or some other materials. So in order to prevent this, we want to keep everything natural so that in the future, the scientists can further study more and without all those contamination from our spacecraft. So NASA has decided that we have to crash Cassini into Saturn so that it won't crash with other moon and will affect the studies in the future. Yep. So this will be it for this picture, and I'll move on to the last one. Right. So this is the astronomy picture of the day for March 3rd of March. Okay. And it has a title of RCW 86 Historical Supernova Remnant, and it's taken by this Neural Lab, National Optical Infrared Astronomy Research Laboratory in the US. But instead, this picture is taken in Chile by this Cerro Tololo Inter-American Observatory in Chile. But the organization is from America. Alright, so what we're looking at here is you can see there's traces of this supernova remnant around here. So you can see it's like a circle. So what has caused this thing to happen? So supernova remnant is when a star explodes and it will leave all these gases and dust around here. And why we call it historical is because that nearly 2,000 years ago, that this Chinese astronomer has already saw this supernova remnant, and it's already been recorded almost 2,000 years ago. So it means that this star has already been exploded at least 2,000 years ago. And also in this image, we can also deduce that this star will be, when it's at the supernova stage, it is a type 1 supernova instead of a type 2. So why is it a type 1? So you can see that when a star explodes, it will leave all these supernova remnant, but there's no more body at the center. So it means that there's no sign of this neutron star at the center or even a pulsar. So yeah, that's this, we can call it a type 1 supernova. But if it's a type 2 supernova, when it explodes, you can see that there will be a neutron star in the middle of this supernova remnant. But in this case, it's a type 1 because we can't see any type 2, any neutron star over here. So, before it explodes, the star will start to collapse as there's too much material and weight. So the stars will collapse, and then it ignites a thermonuclear reaction within the star and causing the star to explode. So currently, scientists also have taken some of the light spectrum of this supernova remnant, and it's found that this supernova remnant is very, very rich in iron. Yeah, it's very, very rich in iron. So why iron? It's because that, in in this radio, how do you call it? The binding energy of this nucleus, right?
Yes.
So iron is found to be the most stable nucleus. So most of it we can find is iron. So as the Earth was created, right? So we can also find a lot of iron within our Earth. So it's because of this supernova remnant. There's a lot. It's quite rich in iron. So after the star exploded, it becomes supernova remnant, and then after that, some of this remnant, this dust, it will start to bound together. It will start to form together, and then afterwards, it will form a new star, and then also some of the other planets. So it's like a cycle, I would say. Yeah. And yeah, this will be it for me. I shall pass to Rayan, is it?
Yes.
Yeah. Okay.
Yes.
Thank you.
Thank you, Sunhit. Let me share my screen. Okay. Can you see my screen?
Mhm. Okay.
All right.
Wait, let it appear. Let it appear. Not yet. Not yet. Not yet. Just wait. Can you see? I don't see. I don't see the temple.
Can you see my screen?
I don't see.
Yeah.
I don't see the Mayan temple.
We can. You are not presenting yet, right?
Yes.
Yeah, we can
Onto
see.
my first image. Now, my first image has to do with something, mine related, called the Kukulkan. Okay, this is the Kukulkan, but I don't think this is the right image. There we go.
There you are. So nice.
Yes, the Kukulkan.
Yeah.
Now, this is a much more interesting image than the last one because this is of the temple of the Kukulkan. Now, in Mayan mythology, Kukulkan is a serpent deity who uses its feathered wings to fly up high and talk to the sun. There are a few various myths surrounding it, but we won't get into that in too much detail here. Basically, it's a Mayan god. Now, what we have here in this image is something referred to as the El Castillo, the temple of the Kukulkan, or as we can see here, the Great Pyramid of the Feathered Serpent. Now, this temple is located in Mexico's Chichen Itza, and it is filled with astronomical features. For example, there are 91 steps to reach the top from each of the four sides. Now, if you add all of those up together and put in the final step of the temple, that comes up to 365. Coincidence? Well, it's the Mayans, so definitely not. It is supposed to match the 365 days in a year. Now, one of the most observed events here at this location is something called the descent of the Kukulkan, which, again, due to the amazing work of the Mayans, occurs at the start of every astronomical spring, a day that we call the spring equinox. The spring equinox is basically one of 2 days in the entire year where the amount of time of the day matches the amount of time of the night. What do I mean? In the Northern Hemisphere, I'm going to use the Northern Hemisphere as the example here because it applies to more people there than in the South. Sorry, Australia. But in the Northern Hemisphere, summer has longer days. So the amount of minutes, the number of seconds you have in a summer day is longer than the amount of seconds in a summer night. It's the reverse in the winter. Winter nights are longer than winter days. Again, this is the Northern Hemisphere. So if you're in the Southern Hemisphere, it will just be switched. Now, on the day of the spring equinox, they match. So the amount of time you have in the day matches the amount of time you have in the night. It's split equally. The astronomical reasoning behind that is that the Earth's rotational axis is 90 degrees, is perpendicular to the sun, and that's how you get the straight split between day and night. This year's spring equinox actually happened a few days ago on Tuesday. So for those in the Northern Hemisphere, spring has started and winter has ended. During the event, if you're here at Chichen Itza at the El Castillo, the shadows cast by this 30-meter tall pyramid, including the 6-meter tall temple on top. So that temple is 6 meters, the rest of the pyramid is 24 meters. They create a silhouette of the feathered serpent god crawling down to Earth. It's a really beautiful thing, and I'll show it to you in a moment. Now, this was built sometime between 700s to 1100s AD, and the pyramid has been subjected to restoration efforts ever since its first excavation in 1931. It's been a UNESCO World Heritage Site since 1988, a full 31 years before Robert Fedez captured this image in 2019. Now, Fedez is an astrophotographer with 6 APODs to his name, the first of which was actually this APOD. So yes, what you're seeing here is a repost from 2019. Now, also in this image is, because it's a composite image, we can also see, my screen is not responding, there we go, Saturn, Jupiter, and Taurus as they seen next to the beautiful, diagonally slanted center of our Milky Way galaxy. The the central band of our Milky Way galaxy. And before I move on, as promised, I will play a short, very short video of the descent of the Kukulkan.
Here.
Observe the shadow.
Yeah.
There it is, slowly descending down. This happens throughout the whole day as the sun moves over during the spring equinox. And right there, that is meant to be the head of the Kukulkan. It slithers its way down.
Ryan, I just want to add on. Can you show the original picture there? The pyramid? Yeah. So just to add on, so this one, I hope you all don't be too scared, young people, because these pyramids are built by both the Mayan civilization in the Yucatan Peninsula and also the Aztec civilization also in Mexico, partly for human sacrifice. It's called heart extraction, crazy, So they carry the young man up and put it on the top of the pyramid on the flat part and remove the still beating heart up to offer to the gods. So that's one of the reasons for they build this pyramid on top is for human sacrifice and to show not only the heart, other parts of the body to the gods. And this is the heart extraction sacrifice. Mayan pyramid. Yeah.
We've progressed much since then.
Yeah.
And we do that.
Thank God. Yeah.
Okay. Now, keeping with the theme of sun-related phenomena over grounded structures, we have this gorgeous image taken by wildlife and landscape photographer Eric Hook. As a landscape photographer by profession, Eric's only other APOD. Eric's only other APOD is of the moon as pictured next to a tree. If you'd like, you definitely head over to the APOD page and check that out. It's another beautiful image. But back onto this. So what happened here? What's the history of this? Well, Eric was driving along the countryside of Knight's Ferry. Knight's Ferry is a county. Well, it's really a community that's an hour and a half drive from the San Francisco Bay Area in California. And he was looking for a nice sunset shot because a heavy storm had just passed by, and he was looking to capture the sunset. And it was then driving along the countryside that he saw this beautiful frame. Now, this image is an elegant representation of the importance of perspective. The rainbow doesn't actually end at the tree. Rainbows don't have an end. It just appears to be located there because of the position of us, the observer, in relation to the position of the sun. It's all about degrees. It's about the angles, the refraction, and the reflection of the sunlight through the air. If we were to actually walk to the tree, we would not see a rainbow there. The rainbow may be further on. If we were to turn around, the rainbow would not be there. That's the beauty of perspective. This whole image really is a representation of perspective, and for us to understand how different perspectives can change what we see. That is the rainbow tree.
Beautiful.
Absolutely. And now, speaking of perspectives have always been of interest, especially in astronomy. Earlier this week, we witnessed Venus's conjunction with the moon, and that's when Venus disappears behind the moon. Earlier this month, Jupiter and Venus reach a conjunction of 0.5 degree. Here in my next image, we're going to talk about the conjunction of Venus and Jupiter. This one was back in March of 2012, when they reached a mere 3 degrees apart. They were just 3 degrees apart. Now, in order to capture this, night sky photographer Marek Nikodem traveled far from the light pollution of the town of Subin in Poland. And he came to this field. Just as the sun set, his daughter got into the frame, striking this ethereal pose as Marek snapped this picture.
Beautiful.
I guess what we see here are in fact Venus and Jupiter. And it's a beautiful image. In fact, this is the type of image that shows us the connection we have with the heavens. This is the type of image which reminds us of the infinite elegance above our heads. It's always there, yet somehow we forget about it. Let's not let that happen. Let's not lose sight of an eternal truth, which is that whatever happens down here, the stars still shine upon us.
Yeah.
Thank you.
Great, very nice, nice picture. Great.
I believe next will be Marcus. I will start presenting.
Yeah, Marcus.
Okay, now I'm gonna share my screen. Wait. First, let me then do. Okay. Can you all see my screen?
Wait. It's coming.
Almost, yes.
Almost. Not share yet.
We could see your screen, but
Yeah,
not
bring in
Okay.
your APOD page.
Okay. So,
What's
my
the date?
first.
Yeah.
My first APOD that I'm gonna be talking about is going to be the March 1st APOD, which is taken by Thomas Royal. He's actually just an astrophotographer. He's he's actually a pilot. He works in the Netherlands. I'm not sure if he's actually Dutch, but I know that he works in the Netherlands. So yeah. Now let's talk about the picture itself. So, in this picture, there's three things: the Flaming Star Nebula, or also known as the IC 405, the Tadpole Nebula, which is also known as the NGC 1893, and Comet ZTF. So, I'm gonna first be talking about the Flaming Star Nebula. Um, the reason it's called the Flaming Star Nebula is because it looks it looks like it's on fire. Though it's not actually on fire. Though it looks like there's like though it looks like there's like a twisted fire, even though there isn't actually fire in the nebula. So and hence that's why it's called the Flaming Star Nebula. It also, and in the center it has a star called the AE Aurigae, which is also called the Flaming Star. It's oops.
Oh.
It's actually really hot. It's so hot that it actually looks blue. And in order to get to that point of like to the point where it's so hot, it becomes the fire looks blue. The temperature has to be around 6,226 to 11,726 degrees Celsius. Yeah. So this is really hot. The star is a main sequence dwarf star, which is like our sun, I believe. I believe, what was it? I believe Sun Yat has talked a little bit about that. So the star is an Orion type variable star, which means that its luminosity is sort of erratic. Like it could go really bright or it could go like really dim. And scientists believe that Orion type variable stars have yet to become like will eventually become like normal stars that have a normal luminosity. And this is also a runaway star. And what a runaway star is, it's a star that has been like it's a star that has an unusually fast velocity compared to like its surroundings. And scientists believe that these stars exist because they've been ejected from their own like family of stars, from the original family of stars. And um for this specific star, scientists believe that it has been ejected during a collision of two binary star groups around 2 million years ago. And the Flaming Star Nebula and the Tadpole Nebula are actually both located in the Auriga constellation. I'll show you that like in a little bit after this. So that's all on have for the Flaming Star Nebula and the Tadpole Nebula. So now I'm going to talk about ZTF Comet. ZTF Comet was actually discovered quite recently, around exactly a year ago, in 2nd of March 2022, by the Zwicky Transient Facility, or ZTF for short. Hence the name Comet ZTF. It's very creative, I know. So you might be wondering, why is the comet glowing bright green? Well, it's actually glowing bright green because due to the effect the sunlight has on diatomic carbon and cyanogen, and scientists believe that there is actually diatomic carbon on this comet, and hence why it's glowing bright green. So this is the Auriga constellation, and and you can see I've circled here where the Flaming Star Nebula and the Tadpole Nebula both are located at. Now, my second picture is going to be the APOD for the 17th of March. Over here. So this was taken by Martin Bradley from the Chesterfield Astronomical Society, which I believe I have it open here. Yeah, this is their website. You can go check it out if you want. You can like go to the APOD for this March 17th and check their website out. So this is called the Medusa Nebula because what well it's because of like the shape of the nebula sort of makes it sort of look like Medusa's like eyes. Okay, so it's located in the Gemini constellation. I believe most of you should know where that is located. It's actually a planetary nebula, and despite what the name says, it's the nebula is not like related to actual planets. It's just called a planetary. Um, it's just called the name is rather misleading. It's not actually related to planets, and this is actually like the last stage of evolution for stars like our sun. Like after our sun will eventually become like a red giant, and then it would soon it would shed its outer layer, and this is what would become of the outer layer of stars like the sun. It would turn into nebulas like this one. And the glow in the nebula wait oops the glow in the nebula is actually powered by the star's ultraviolet radiation, and this nebula is actually estimated by scientists to be around 4 light years across, so it's quite a big nebula. And now for my last APOD for the day, it's going to be the Wolf Riot 124. This is actually not taken by one person. It was taken by a couple of organizations: NASA, ESA, which is the European Space Agency, CSA, which is the Canadian Space Agency, STC1, which is this one over here. You can see this is their website. Looks pretty cool, and and the James Webb and the James Webb Early Release Observations Team. So yeah, this was actually taken by the James Webb Space Telescope, which is why you could see there's six edges to each of the stars, which I'll explain why in a minute. So yeah, so this was taken in infrared view, and it has a 6 spike star pattern because there's 18 hexagonal mirrors installed on the James Webb Space Telescope, which causes it to look that way. It's located in the constellation of Sagitta, which I will also show you in the next slide. And this is actually almost 30 times the mass of the sun. Okay, so I should also clarify that Wolf Riot 124 is actually a star, the star you can see in the middle over here, and the thing surrounding the thing surrounding the star is actually material that has been expelled by the star, and it's a separate nebula called M1-67. The nebula is quite turbulent, which scientists believe might indicate that the star is actually near the end of its life, and it's nearly 6 light years across. So it's bigger than the previous nebula that I talked about. So, right. So this is how the Sagittarius constellation looks like. I actually could not find one that would show, like, that would label where Wolf Riot 124 is located. So yeah, the constellation is shaped in the form of an arrow. So yeah, um that's gonna be it for me today. So yeah.
Thank you, Marcus. So I continue with our APOD for 10th of March 2023. There you are. And of course, the moment you see it, some of you say, hey, we already know yet it's true. So boys, this is about the most, other than, of course, sun, moon, and the planet, the most photographed astronomical object from planet Earth, all right, which is our Great Orion Nebula, or M42, all right, taken by Abraham Jones, American astrophotographer from West Virginia. West Virginia is somewhere near Washington, D.C. And of course, it's about 1,500 light years from us, okay? And then there's a lot of story about the Great Orion Nebula. You start with the general story first. So you basically have a nebula here, which is nebulas are about three types. Emission nebula, the bright one, and the dark one, absorption nebula, meaning the light from behind the dust cloud has been blocked by this dust cloud. So this absorption nebula. And there's a third one, sometimes possible, where you have a star there emitting light, hit on a part of the nebula, reflect off. Reflection nebula. Okay? So you have emission nebula, absorption nebula, reflection nebula. And of course, here you have the famous Running Man nebula. All right. Remember, welcome to the Astronomical Zoo. All right. But in this case, the zoo is not an animal, it's a man. So if you see carefully, it's supposed to be the part of a man. The man is like lying down horizontally. The head is there. They don't show his arm. It's the right leg. This is the left leg. So this is a Running Man nebula. So by the way, many times when you show this, you give a talk to the young kids, they will think that, oh, you mean to say, sir, in space, they're full of dust, meaning that if a spaceman were to go into this nebula and do a spacewalk and remove the helmet, the spaceman will choke. Choke. So much dust and gas in space. No. Even the dust cloud shown by Sunil just now in Taurus is actually vacuum. But because it's a large part of space, it looks like a thick full of dust and gas. More. Actually, it's a vacuum. In other words, even a vacuum on the Earth that you produce, the vacuum here in this nebula is better than the vacuum on the Earth, meaning very little atoms inside. But because there's a lot of volume of space involved, it looks like it's thick smoke. Actually, it's a vacuum there, right? If you go into it, all right? So you have here also the Running Man nebula. Of course, this is old information. Remember, Hubble Space Telescope was set up in the 1990s, 30 years ago. And within a few years, Hubble took a lot of pictures from here inside the middle of M42, and they found out many of the famous proplyds, PLYGS, the protoplanetary disk, where meaning that the famous bulk globules, or all types of absorption cloud, where that's what you call, absorption nebula there, where the stars are collapsing, the gas and dust are collapsing, and new star system will be born. And you know how many of these proplyds Hubble have discovered? Don't fall down from a chair. A few 100,000. A few 100,000 proplyds have been discovered here. And new stars are being born. So this is what you call a stellar nursery. Tadika Bintang. Okay. We go to the next picture, which is the 9 March. This one I'm sure many of you were aware of it last year. Sometime in September last year, all right, you have the DART mission, DART, versus Dimorphos. So Dimorphos is this small, part of this binary asteroid, where this spacecraft by DART, sent by NASA, crashed into it. And this is about 3 seconds before crashing into it. So, of course, the spacecraft you don't see, but you compare that if the spacecraft were to hit the asteroid surface, which is Dimorphos, this is the center part of the spacecraft. This is a solar panel just before hitting. All right. So this is a famous DART mission. And remember, it was around 26 September 2022, last year, where this spacecraft hit into this what they call Dimorphos, the binary asteroid. So what is that? That is a double asteroid redirection test, meaning that you have a big asteroid called Didymos and a small what they call binary asteroid called Dimorphos, or I call it the sidekick lah. The sidekick is Dimorphos orbiting around it. So NASA is trying to test your technology. If you send a kind of projectile to hit an asteroid, can you deflect it or not? Why? In case in future you have an asteroid that may hit the Earth after some years. So maybe humanity discovered, come with the technology to hit that asteroid far before it approaches the Earth, so that far away you hit the asteroid. So by the time you come near to Earth, the slight deflection very far away, by the time you come near to Earth, it will miss the Earth. So you try to test this technology. And then they found that after hitting the Dimorphos, this small binary asteroid, they find that remember it's a bigger asteroid, Didymos, smaller one, the binary asteroid, and orbiting around each other. So previously, before the impact, they find that the small asteroid, Dimorphos, will take about so long to orbit around the bigger asteroid. But after the impact, it was slowed down. It took 33 minutes less to make an orbit around the what they call the bigger asteroid. Originally, they thought it would take only 73 seconds less to orbit, but they found that it was 33 minutes longer to orbit around the bigger asteroid. So that means this technology is working. So maybe in future you have an asteroid that discovered that on direct collision with the Earth, to send a kind of spacecraft far ahead and hit it, so that by the time it comes near to the Earth, it will miss the Earth. It's no point in hitting the asteroid when it's near to the Earth, say when it's orbit of Jupiter coming towards the Earth, you try to hit it. The amount of kick you give in it, the change in the momentum, the velocity will not affect it much. You still hit the Earth, but you hit it when it's far away, so maybe somewhere near Pluto or somewhere far away. So by the time you come to the Earth, it will miss the Earth. So this is the technology here. So this is our double asteroid redirection test that was done what we call last year on 26 September 2022. Okay, we go to the next one. 8th of March. This one is that one I'm sure you all know already. Okay, so I make it bigger. So this is artificial night sky brightness. Okay, so basically by this satellite, JPSS satellite, and processed by David J. Jones. So David J. Lawrence is actually a kind of a climate scientist, studying the climate of the Earth. So he did it. So this satellite orbit the Earth, and there is in the polar orbit. When you want to take a picture of the Earth, most of the spy satellites are in polar orbit. That means you don't orbit around the equator. You will miss the pole, north and south pole. But you orbit around the north and south pole, the Earth will rotate under the orbit of the satellite. So so maybe after a few days, all parts of the Earth can be imaged. So this at night. So you see, of course, we know lah. Of course, the terrible regions are Europe, southern England, Italy, and part of this Middle East. And look at the Ganges Valley. Oh, yo. And look at Malaysia. I cannot enlarge this picture because you enlarge it doesn't work. But you see here in Peninsular Malaysia on the west coast, Singapore, right? Okay. And of course, in the North China Plain and South Korea, North Korea is of course dark, South Korea, and of course, practically the whole of Japan. Of course, in North America here, you see very bright. So this is the light pollution. Okay. So this one, we cannot do anything. So remember, you have this thing which many years ago we are promoting in Malaysia, International Dark Sky Association, IDA. They have been trying to monitor light pollution all over the world. Okay, so now we find that in many of the parts, according to this picture, you see the red part. The red part means cannot see the bright part of the Milky Way. The bright parts are places in the world where you cannot see Milky Way in those places, even if there are no clouds, right? Because too much light pollution. But in Malaysia, west coast of Malaysia, difficult, including Penang Valley, but into the inside, mountainous area, say Bentong, Kelantan, Pahang, can still see. So we know in Malaysia that we always talk about the bottle scale. So in West Malaysia, we don't find places which are very dark. All right. Bottle 3 and 4 also difficult. Bottle 5 and above. But I think in Sabah, Sarawak, you can still find quite low bottle numbers. Right? So this is the light pollution around planet Earth. But you see here, Africa, very good for stargazing, dark. Sahara Desert, Amazon jungle. Okay. I've got this place, the biggest place for stargazing in the world is the world's oceans. All the oceans are very dark because only have ships there. And even you have islands in the middle ocean, there are not much people there, not much light pollution. But unfortunately, if you put a telescope on a big container ship or a big ship sailing or cruise ship in the Central Ocean, it will rock a bit. It will drip a bit. So you don't have steady. You cannot do polar alignment because the ship is moving. That's the problem. So maybe if you can take a ship to some of the small islands in the ocean around the world, you land on dry land, and then you do exophotography there. So you see, it's getting worse and worse, the light pollution all around the world. Okay. The next one is 7th of March. This is quite, we are also quite common, you know this, Deep Field, the last Magellanic Cloud by Yuri Bereski, Carnegie Last Campanas Observatory. Now remember, Carnegie is a very rich, what you call a foundation in America, and they give money to build the last Campanas Observatory in Chile. Right, Chile, where many of the big telescopes are located, and our Yuri Bereski is the instrument support scientist for this place. So he took it, of course, the big telescopes are there, and it looks like a galaxy. It's not. It's a satellite galaxy, right? In the large Magellanic Cloud. So we know that our Milky Way is a big dark spiral galaxy, and in the southern part of it, two of the sidekick. The big one is called Large Magellanic Cloud, LMC. Small one is SMC, Small Magellanic Cloud. Because even then, in the Large Magellanic Cloud, there should be billions and billions of stars. It looks like a dark spiral galaxy. It's not. It's an irregular galaxy, right? Large Magellanic Cloud. So if you go to many places in Malaysia, like years ago, we went to Langkawi. At a glance, you can see Milky Way. You can see the LMC and SMC. So lucky, all right? And of course, all these points of light here are the stars in our main galaxy itself, the foreground. So this large Magellanic Cloud is further away, and in the foreground is the stars in our main galaxy itself, the Milky Way galaxy. Okay, so go to the 4th of March. Okay, this one, the quality of the image is not good, but the way it was taken was great. No, I really salute to our Mr. This is 10 days of Jupiter, Venus, and Jupiter. Means one day. Okay, which means that this is our Jupiter, Venus. Second day, Jupiter, Venus, and the Moon, crescent Moon. And then the third day is Jupiter, Venus, and 10 days it took it. Why different color? Because the place it took it on was in a place in India, all right, near called Dhanbad, India, Jharkhand, near to West Bengal, all right, near to West Bengal. And this guy, Mr. Sumyadip Mukherjee, very, very creative. He took it with the same camera on the stand, on the same location for 10 days, and he joined them. You see that what? So you have a rendezvous, a meeting between our two planets, Jupiter and Venus, in the Earth sky. So come here, and there you are on that date. They are very close, a close conjunction. So they are going to come here. So basically, why is this happening? It's like this. Remember, Venus is orbiting around the sun at a faster speed. Jupiter is orbiting also around the sun at a slower speed. So as time comes by, the Venus will come closer and closer, faster, and overtake Jupiter. So basically, the bottom one, Venus, is going faster, orbiting faster to overtake Jupiter at this point. So very nice, huh? So 10 days of Venus and Jupiter. All right. So imagine now, you can say that you are in a big sports stadium with a running track. Huh? So Venus is on the inner lane. Jupiter is on the outer lane. So Jupiter on the outer lane, the guy on the outer lane is running slowly because it's further away from the sun. The sun is in the center of the stadium, and Venus is a bit away from the center of the stadium because it's closer to the sun. It moves faster. So on the inner track, Venus is running faster. on the outer track, Jupiter is going slower. So this is the case. So very nice. So the idea is great. All right. So I think that's about all for today from me and from us. Go back to the presentation. Everyone. Okay. Yeah? So well done, everyone. So any question? There's
No.
Rain, any question?
Um,
Facebook, YouTube.
Not sure about Facebook. I don't
Oh,
think
any question you want? Any comment? Okay. One thing on Marcus, when we present it, we always start with the later date. You should have started with March 18, first picture for you. Second picture for you is March 17. Third picture is March the 1st. That's what all of us are doing. You started with the 1st or March 1st. Second is 17. No, start with the later one. March the 18th, March 17th, March the 1st. Okay. Any
No.
comment, any question?
No.
Or maybe, Michael, thank you. You can stop the streaming now, but maybe we can discuss among ourselves. Yeah, okay. So thank you everyone for watching our Astro Society of Penang astronomy picture of the day presentation for March. That means 26th of March 2023. All right. So we hope to bring you in future more events, more interesting pictures. So we hope to get even more pictures from James Webb Space Telescope, and also we can inform you some of events. For example, there's an event coming on the 20th of April that's going to be a hybrid solar eclipse observable from Asia, and some of our members are going to Australia to see the total or hybrid solar eclipse. But some of us will be in KL, the capital city of Penang, to observe it. 20th of April, partial solar eclipse, as seen from Malaysia. Okay, thank you very much for staying with us. Thank you again.
Thank you for watching.